Hey guys, welcome to our video. I wanted to talk about this related rates problem. So it was giving us a little bit of trouble in class, and I just wanted to break it down and explain it a little bit more in depth. So you have this trough, and we have the isosceles triangle, okay? And here's what I want to think about for this problem, okay? Given that information, we can break down this isosceles triangle into the 2, root 2, root 2, and then you can also determine that this bit here is 1 because you're forming 2 more isosceles triangles. And so that is why this works here. Okay, this other triangle over here represents the water. So the base being the water line, and then the h being the height of the water. Okay. Now, when you're solving related rates problems, I typically try to write down related rates that I know and rates that I want. So you can see I wrote down that dV/dt is equal to 2, and I want that dH/dt, okay? Because I want to know at what rate is the height h of the water in the trough changing 2 minutes after the water begins to flow. So then based off of this triangle relationship, I have that 2 is to b as 1 is to h just by setting up ratios. And that gives me that b is 2h. Okay? So that's where that information was coming from. Now we can go and do the volume. So the volume is the area of the cross section times the height. So the area of that cross section, it's a triangle. It's a half times 2h times h, and then we're multiplying it by 9. Then we can simplify that down to get that v is 9h squared. This is where the differentiation comes in. We then take dV/dt, and we're going to get 18h times by dH/dt. Since we know that dV/dt is 2, we can substitute that in, and now we have something here. We have this, the rest of this here. Solving this for dH/dt gives me 1 over 9h. At this point, I kind of thought, well, what's going on? It's in terms of h. But if you look back at the question, it says, at what rate of, how is it changing 2 minutes after the water begins to flow? And so 2 minutes, okay? It's been flowing for 2 minutes. What's the volume of this water at that point? Well, it's 4 because it's been 2 cubic feet per minute. And so if you solve that, you get h is 2/3. Substitute that into your equation for dH/dt, and you'll get the answer of 1/6. All right, guys, I hope you like that explanation. If there's any further questions, let me know. If you want me to do more related rates questions, happy to do so. Have a great day. Have a great weekend, and I'll see you later. Take care.